Hello everybody, welcome back to another video. In this video we're going to focus on the question 5 from the AP Calculus 2003 response portion. So in this problem we have an expression given in implicit way. So basically in part A it says show that dy over dx is equal to this expression on the right hand side. So in order to verify this we need to apply the implicit differentiation to the given expression. So let's do it. In part A I'm going to implicitly differentiate each of these expressions. Okay, so we get y squared plus 2y times x times dy over dx and minus 3x squared y plus x cubed dy over dx. So basically we're going to treat dy over dx as like a variable, and then at the end we are supposed to solve the entire equation for dy over dx. So let's continue. So y squared plus 2 times xy dy over dx minus negative 3x squared y minus x cubed dy over dx equals 0. So what I'm going to do is I'm going to continue here. So what I'm going to do is I'm going to combine all the terms with dy over dx. So basically, so when I factor out of dy over dx, we're going to get 2xy here and minus x cubed. And also I'm going to move the other expressions. to the right hand side, so we get 3x squared y minus y squared. So I'm going to divide each side by 2xy minus x cubed to get dy over dx isolated. So we get 3x squared y minus y squared is equal to divided by 2x y minus x cubed, which is same as the answer in part A. So we just get it verified. Okay, so let's move on to part B. So in part B, what we're gonna do is it says find all points on the curve whose x-coordinate is 1. So we know that the x-coordinate is 1. So in order to write down the equation of tangent line, we need the y-coordinate, okay, and we need also the slope. Okay, so in order to find the y-coordinates, I'm going to take this x equals 1 and plug it into this given expression. So we get 1 times y squared minus 1 cubed times y equals 6. From here we get y squared minus y minus 6 is equal to 0. So this expression can be factored into y minus 3 times y plus 2 equals 0. And from here we get this result, the solution y equals 3 and y equals negative 2. So now is the time to figure out the slope. So we need to figure out the slope at this point, 1 comma positive 3. So basically dy over dx 1 comma 3. So basically we're going to go back to our solution right here and we're going to substitute 1 and 3 for x and y. So let's do it. 3 times 1 squared times 3 minus 3 squared divided by 2 times 1 times 3 minus 1 cubed. So basically this expression will be 9 minus 9 over 6 minus 1. So this is going to be equal to 0. So basically at this point the slope of the tangent line is just 0. So the equation will be like this. If we apply the point slope form, y minus 3 equals 0 times x minus 1. So from here the tangent line equation will be just y equals 3. Okay, so at this point 1 comma negative 2, let's try to figure out the slope. So dy over dx 1 comma negative 2. Again we're going to plug in 1 for x, we're going to plug in negative 2 for y. So let's do it. 3 times 1 squared times negative 2 minus negative 2 squared divided by 2 times 1 times negative 2 minus 1 cubed. So this result is going to be equal to so negative 6 minus 4 This is going to be -5. The slope is going to be equal to just 2. So again, let's reapply the slope intercept. Point slope form. So we get y minus -2 equals 2 times x minus 1. From here, our tangent line equation will be just 2x. So 2x minus 2 minus 2. So right here, our tangent line equation will be 2x minus 4. Alright, let's move on to part C. In part C, it says find the x coordinate of each point on the curve where the tangent line is vertical. So if the tangent line is vertical, that means in our slope, the bottom expression has to be equal to 0. So basically, 2xy minus x cubed has to be equal to 0. So this expression can be factored into x times 2y minus x squared equals 0. From here, x is going to be either 0 and 2y minus x squared will be 0. From here, y is going to be equal to x squared divided by 2. Okay, so if you remember that, I'm going to write it here. So the horizontal tangents can be expressed like y equals a number, okay? And vertical tangents can be expressed as x equals a number, okay? So in this case, that's why I'm going to go back to the original function, as you can see. Alright, original expression. Whenever I see y, I'm going to substitute x squared divided by 2. So that expression is going to be equal to x times x squared divided by 2 to the power of 2 minus x cubed times x squared divided by 2 equals 6. From here, we're going to get x to the 5th over 4 minus x to the 5th over 2 equals 6. So then from here is going to be equal to negative x to the 5th over 4 equals 6. If we do cross multiplication, we're going to get negative, let me use different colors. So we're going to get negative x to the 5th equals 26. And from here, we need only positive x to the 5th. So x to the 5th is going to be equal to negative 26. And if I take the 5th root of each side, we're going to get the vertical tangent as under the 5th root, negative 26. So that's our solution for part C. Alright guys, thank you so much. In this video, we talked about the solutions of question 5 in 2000 AP Calculus 2000 for response portion. Thank you so much for watching. See you in the next video.